Hello, welcome to Intro presented by the SchrDbb. In this tutorial, we're going to see investigations and interpretations. Now, for investigation and interpretation tutorial, we're going to first start with, we have different things that we're going to see. We're going to see full blood count investigations and interpretation. We're going to see the second one is chest x-ray investigation and interpretation. Then the other ones, there are many. We have CT scan in investigation and interpretation. So depending on how many you want also to do as investigation and interpretation, we have also urinalysis investigations and interpretation. Is it clear? Now, recently I was asked by one of the subscribers that we should do on full blood count and chest x-ray interpretation, so I'm going to do that only. If you want other investigation, you can just contact me either with the comments or through my contact. So we are going to work. So yeah, there are many investigations that can be interpreted in medicine. There are just many. Basically, we are going to here start with full blood count. Full blood count investigation and interpretation. Now, full blood count. When we are doing the full blood count is there to assess the general blood, how the blood it is, basically. And generally, you need to know that what blood is made up of two major aspects. It is made up of the blood cells and it is made up of the blood plasma. Now the blood cells are visualized with the full blood count. So the full blood count can help us have an idea on the white blood cell, have an idea on the red blood cells, and have an idea on the thrombocytes. So now, what are the elements of the full blood count? So every time they ask you for full blood count interpreted, so what are the, let us first start with the elements of the full blood count. Elements of full blood count. So the elements of full blood count, we need to know that the first element in full blood count is the white blood cell count. And under the white blood cell count, we have which predominance. It can be lymphocytic predominance. You have the lymphocyte underneath. You have the granulocyte underneath, and we have the monocyte underneath. Is it clear? So generally the lymphocyte is written as LYM. The granulocyte is written as GRAM, and the monocyte written as MID with a slash like that. All of them are having slash at the end. Are you getting? So that's how we write each of them. And I'm going to later on give you the significance of each of the predominance. Are you getting? Now, the next part of the full blood count, after visualizing that on the full blood count, we have now the part of the red blood cells. The red blood cell part is not very important. What is actually important is the HB or the hematocrit. Basically, the HB is what is going to tell you. So the HB is very important. It's another aspect that is very important. And you can also have the hematocrit. If you don't have a HB on the full blood count, look for the hematocrit on the full blood count, because the hematocrit, the HB, the formula for the HB is equals to 3. Generally is considered as 3 times the hematocrit, and implies that so generally the the hematocrit is equals to 3 times the HB. So it implies that the HB is equals to hematocrit divided by 3. So if you don't have the value of the hematocrit, you can just use if you don't have the value of the HB, you can use the hematocrit in order to get the HB. The next thing after that, visualizing on the red blood cells. For the red blood cells also, you have the next part that you need to evaluate is the mean corpuscular volume on the full blood count, which is written as MCV. The mean corpuscular volume is very important. Now the next thing that is important is the mean cell hemoglobin consent. We have the mean cell Is it clear? The mean cell hemoglobin. The mean cell hemoglobin is written as MCH, or some people like using the mean cell hemoglobin concentration, which is MCHC, but I better prefer to use a mean cell hemoglobin than the mean cell hemoglobin concentration, because this one is going to show you the concentration is similar to the HB, but this one is more for a particular cell. So I prefer this one and this one when I want to evaluate just one cell. This one is a concentration, so it's going to evaluate the hemoglobin of many cells. So it's just going to give you the same parameter just like the hemoglobin. So I prefer the mean corpuscular hemoglobin, the mean corpuscular volume, and the mean corpuscular hemoglobin when I want to evaluate just the hemoglobin inside one cell. Now the next element after evaluating now for the red blood cells, we have now the next parameter, that is for the thrombocytes. Basically the thrombocytes. Now for the thrombocytes, you need to know that it is actually the thrombocytes count. There is nothing to add on it. The thrombocytes are the thrombocytes. You have the actual thrombocyte count. After the thrombocytes, you have another part which is called the red cell distribution rate. Basically the red cell distribution rate, the red cell distribution rate, which is written as RDW. Now there are two red cell distribution rate. There is RDWCV and there is RDWSV. Now C, it can just be guessed to be approximately equal to the chromasia, is equal to the chromasia of the red blood cell, so the colorization of the red blood cell, while the S is there for the size. Now the question is what does this red cell distribution rate mean? Actually, the red cell distribution rate means that there is a different, the larger the red cell distribution chromasia, it means that there is a large difference between the colorization of the red blood cells. I hope you're understanding. Red cell distribution rate is the difference in the red blood cells. When you have the RDW, the red cell distribution rate is a difference in red blood cells. When you have when you have a high red cell distribution rate, CV means that there's a different colorization of the red blood cell, the chromasia of the red blood cell. And when we have the red cell distribution with SV being very large, means that there's a difference in size of the red blood cell. Now the difference in colorization of the red blood cell is going to be called what? Is going to be called polychromasia. So it can help you to guess that there's polychromasia already inside the red blood cell. And this one is going to help you to guess what is called anisococytosis. That's difference in the size of the red blood cell. Is it clear? So those are the different elements that you have to evaluate. Then the next point that we're going to do is to know the normal values of each of them. Basically, now the white blood cell count normally the values of each of them is going to range now with respect to different cases. So these are the elements, and then the next point that we're going to do are the normal value of each of them.